In this video, we're going to look at a powerful feature of the software called toolpath templates. This allows you to do is create a set of toolpaths for one job, export them as a template, import those into a different job, and then reapply the toolpaths to a new set of design vectors. This can be a tremendous time saver and really help to automate a lot of different processes. For our example, we're going to show you how to apply this to a cabinet design that's been created in another software program. But it's important to understand that the templates have a lot of benefit for many different applications, and so even if you're not a cabinet maker, it would still be very worthwhile to watch this example and see how they might apply to what you do and how they could be used as a time saver and a way of creating consistency across different jobs. So we'll start here by opening an existing file. Let's click on the link, and from the project folder I'm going to choose the file samplecabinet.crv and hit open. Now this is a special file that I've set up which will allow us to set up our toolpath template. It's important when we set something like a toolpath template up that the file we create it in has an example of all the different types of data that we're likely to come across in future versions that we want to apply that template to. So that's going to include all the different vector types and shapes, but also all the different layers that I'm going to want. And this is very important, particularly with the type of template we're going to set up, because we're going to associate different toolpath types with specific layers and specific layer names. So before we start calculating our toolpaths, let's look at the different types of data that we've got in our part. The first three layers all contain holes that we're going to drill. We can see those if we just click on these light bulbs to switch the visibility on and off. You can see those appear and disappear in the 2D view. Then we have 6 layers which all represent dados in the part. So again, I can either click the light bulb on and off to make those appear and disappear, or we might want to select those to show where they are. So I can right mouse click over the name of the layer, come down and choose select layer vectors from the list. Another way to access that same list, if I just click to deselect, is to click on the list icon to the right here and then to choose select layer vectors. So if we can see on that particular layer, bottom blind dado, we've got 2 vectors in this part. If we deselect by clicking in the white space, click on one of those, at the bottom it's showing me the width and the height of that particular selected vector, the W value here and the H value right at the bottom of the interface. It also shows me the layer name of that particular vector. Now in this case, what I'm planning to do with the dados is cut them with a 0.375 or 3/8 of an inch wide tool. So for a dado like this, which is only 5/8 of an inch wide, the most efficient way for me to machine it is just going to be to profile around the inside of that. However, some of the dados I've got, like this one here, are too wide for me just to profile around. You can see that that's over double the diameter of the tool. So in that case, what we'll need to do is pocket that particular area out. So I just need to be aware of that as I go through and calculate my toolpaths. Let's just deselect this now. I'm going to hit F on the keyboard in order to fit my 2D view back into the window so we can see all of it. Now what I'd like to do is open the toolpath tab and start calculating my toolpaths. As I'm doing this, I think it'll be beneficial for me to be able to see the layer list over on the left here. So I'm not going to minimize the layers tab. I'm just going to open the toolpaths tab so I can see them both. So I'm going to come over where it says toolpaths here on the right. That'll make the toolpaths tab appear, and then I can come up and click on the pin to pin that in place. Next, we're going to set up our material or double check the setup for it. So here we're going to click on the set button at the top of the toolpaths tab, and I want to double check material Z0 set to the top of the block. In this case, my material thickness is 3/4 of an inch. XY datum, the X0, Y0 positions in the lower left hand corner, and that my rapid and home positions all have reasonable values that are safe for my particular setup. So I'm happy with those. I'm going to hit OK. Remember, if you do plan to run any of the toolpaths you're going to look at in this presentation, you need to ensure that all the values you enter are appropriate for your particular machine, your setup, your tooling and your material, so that when you run them it's going to be safe. So typically when we're calculating toolpaths within a job, we manually select the vectors from the 2D view, click on the toolpath icon and apply a set of parameters and tooling to it and then calculate that toolpath. In this case, because we're preparing our template, what I want to be able to do is select vectors in such a way that the software will be able to apply that in other parts. And we're going to do that based on a specific set of criteria to do with the type of vectors and the vector name. Where we access that is from within each toolpath form as we set up that specific toolpath. So without selecting any vectors, I'm going to click the first type of toolpath that we're going to calculate. So I'm going to come down and click on the icon for the drilling toolpath. I'm going to set up the parameters for our first drilling operation, and then we're going to come down and use this button here to select our vectors. So start depth for this first set is going to be 0. Cut depth, I'm going to drill down 1/2 inch. I'm going to hit the select button, and from the tool database I'm going to choose the 1/4 inch drill from the drill section there. So I'm just going to take the default values for the feeds and speeds for that, go ahead and hit OK, and I'm also going to take the defaults for the rest of the drilling form here. I'm not going to use the PEC drilling or the vector selection order. What I am going to use though is this vector selection and this selector button. You can see at the moment it's set to manual, and that would just infer that I wanted to go into the 2D view and pick these vectors individually with the mouse. Here though, we're going to click on the selector button and I'm going to choose the criteria for how the software is going to select these vectors. In this case, I'm going to say I want to select closed vectors, only circles, and only circles on this first layer called hinge holes. Now if I was to hit close and calculate at this point, it would use this selection criteria, but it would only use it once and it wouldn't remember it. If I want the software to remember this information and use it every time it recalculates this toolpath, I need to check this box here to associate with the toolpath. This is very important and something we're going to check for every single toolpath we calculate in this part. The reason being that if we don't check that, when we save the template and we use that template on another part, it's not going to remember this selection criteria. So with that checked, I'm going to hit close. Now I need to make sure I don't click in the 2D view now, otherwise that will go back to being manual selection. What I do want to do is change the name of this toolpath to match my layer. That's not going to have any bearing on the selection, that's purely for organisation. The easiest way for me to do that accurately is to copy and paste the name from the layer list. So I'm going to click in the layer list on the name, that's going to select it, I'm going to right mouse click and choose the option to copy. That'll copy that text onto the clipboard. Then I can click in the name over here, drag with the mouse, let go so the text is highlighted, right mouse click and use the option to paste. So that's just taken the text and pasted it from the layer list where we copied it into the name of that toolpath. As I say, that has no bearing on the vector selection criteria. That was all done in what we defined under the button here. Now we can hit calculate. The software will look at the options we've chosen there with the vector selection, the tooling and the parameters, and it'll give us our first toolpath. Now we can preview that if we want. There I can see some small holes being drilled into my material if we look closely. I'm just going to go back to the ISO view, then we can close that preview. And what I am going to do while we calculate our other toolpaths is just tile the windows. So I'm going to go up to View, Tile Windows Horizontal, and that'll show me the 2D view at the top and the 3D view at the bottom here. So now let's just repeat that operation for the next two layers and the holes that are on those. I'm going to use exactly the same machining parameters for each of those, so all I need to do is click on the drilling toolpath icon. It'll remember the values that I had previously set, so I just need to come down and click on the selector button. I'm going to choose closed vectors, only circles, but for this second one I'm going to choose a second layer called shelf holes, and again very important to remember to check this box, associate with toolpath. I'm going to hit close, and once more I'm going to copy and paste the name of the layer, so I'm going to click on the layer to select it, click on the name so I can go into the editing mode, right mouse click, choose copy, come over here, click in the name area of the toolpath form, highlight that with the mouse, right mouse click and paste and hit calculate. Again, we can preview that if we want, so we can see the holes being drilled in there. If we look closely, I can close the preview, and I'm going to repeat the same operation with the third layer. So I'm going to come up, click on the drilling toolpath icon, same parameters, hit the selector button, closed vectors, only circles, pick the third layer from selected layers only called draw holes, click on the box to associate with the toolpath, close that, and again I'm just going to click to select that layer, click to select the name, right mouse click and copy, and then come down the bottom and highlight, right mouse click, paste, calculate, and preview that selected toolpath as well. Now at this point I'm going to hit close. Now you can see that we've calculated 3 different toolpaths, but in each one we've used exactly the same set of parameters. So in theory I could have calculated a single toolpath and just associated it with the vectors on all 3 of those layers using the vector selector. The main reason I haven't done that is to give myself more flexibility when using this template on future parts. For this particular setup, we do want exactly the same parameters, but it may be that on a different design that I would like to have different depths for the holes, or maybe I'd like to change the tool and drill the holes with different sizes or different types of drill. So by doing these each as a separate toolpath associated with a single layer, that's just built in that extra flexibility, and it's just one of the things that's worth realizing with the templates is sometimes it's worth putting a little bit of extra time into the setup to give yourself that flexibility later on. So the next thing I want to do is calculate all the toolpaths for my dados. In the same way that we calculated a separate toolpath for each layer with different holes on it, I'm also going to calculate a separate toolpath for each layer that's got dados on it. You may remember earlier on we talked about the fact that some of the dados, if we zoom in here in the 2D view, are thin enough for me to just profile inside of those with a 3/8 mm to machine out all the material. Some of the dados, however, are not thin enough, and if I profiled around them would leave a thin piece of material in the middle, so for those I'm going to have to use a pocket toolpath rather than a profile. What I'm going to do is just take a moment to organise my data so that I've got those dado layers essentially grouped together. This is just organisational. So what I'm going to do is take backside dado here, select that layer and just move it 1 down in the list with the arrow, and I'm going to take back bottom dado here and use the arrow to move that 2 down. So now I've got bottom blind dado, side blind dado and top blind dado here together in the list, and I know from having looked at the data that each of those I'm going to be able to profile. Back bottom, back side and back top are all going to need to be pocketed. So essentially I've just moved those together, so I'm just grouping those layers in a logical order for me to calculate my toolpaths. So let's start with the first one that we're going to profile, which is this bottom blind dado layer. I can select that layer if I want. That has no bearing currently on what I'm going to choose when I come to machine this though. That's all going to be done using the vector selector again within the toolpath form. So if we come over and click on the icon to create a profile toolpath from the toolpath operations, within here I want to machine down 3/8 of an inch, 0.375, so I'm going to enter that for the cut depth. I'm going to hit select under the tool area of the form. What I want to do is use a 3/8 inch end mill. Currently I don't have one set up within my tool database, so I'm going to use this 1/4 inch end mill here, make a copy of it and then just edit some of the parameters in order to give me my new tool. I could also just click the new option. In this case I'm going to click the option to copy that tool. When you copy a tool though, you need to be extremely careful when you edit the data to make sure that you change both the diameter and the name to match. For instance, if I come down and change the diameter of this to be 3/8 of an inch, 0.375, the name is not necessarily going to update automatically. So currently, if I was to hit OK with this particular tool, the name is going to show me it as a 1/4 inch tool, but inside the software is going to think of it as a 3/8 of an inch tool, and that is definitely a situation that could cause me problems. So as soon as I change the diameter, it's very important I come up, change the name so that it's reflective of the data for that particular tool, and I can give this tool any name I want. I can include information about the manufacturer, parameters I've set up for it, material types, anything like that, just anything that's going to help me select the right tool and know what parameters are associated with it. Coming down, I'm going to change the pass depth for this tool to 3/8 of an inch as well. Spindle speed 12,000, feed rate 300, plunge rate 60, hit apply. We can see the name update in the list there under the M mils. I'm going to hit OK to select that tool, and we can see that updated in the form. Now I'm going to do a profile toolpath to clean out these dados, and so I need to profile inside the vector. We want to go clean out the inside of the rectangle. We don't want to machine on the outside, so I'm going to choose the option to machine vectors inside. Then I'm going to ignore all the other settings in here, take the defaults and just come down, and again using my vector selector I'm going to come into the form, choose closed vectors. This time I'm not going to select only circles because these are rectangles, and I'm going to choose from the list bottom blind dado, and again make sure you click the option to associate with toolpath, hit close. I'm going to come over, click to select the name here, right mouse click, copy, highlight, right mouse click and paste that name in there and hit calculate. There's my toolpaths. So if I want to preview that, we can. You can see I've currently got a global fill color set for my profile toolpaths. We could set that to a different color if we want. Maybe we'll choose something like yellow to make that very visible, and that we can look at, just ensure we're cleaning out all the material within our dado. So let's go back to tiling the windows. Go up to View, Tile Windows Horizontal. So now let's repeat that process for the vectors on the next two layers. We'll close the preview form, come up and click on the profile toolpath icon. It will remember the last set of parameters that we entered on this form, so we can see these should be correct, assuming we want to apply the same toolpath to the next set of vectors. So cut depth 3/8 of an inch, 3/8 mm, machine inside the vectors, so I can just come down, click on the vector selection button. I'm going to choose closed vectors. This time I'm going to choose the side blind dado layer, associate with toolpath, hit close. I'm going to come up, select the layer, click on it again to highlight the name, and as well as using the right mouse click menu to copy and paste this, I could also use the shortcut keys. So with the name highlighted there, the shortcut key to copy that is Control on the keyboard and then hitting C. So you hold Control down and also hold C down on the keyboard, that'll copy it. Then we can click down here with the mouse, highlight this name, and to paste it we're going to press Control V on the keyboard. So Control C to copy, Control V to paste, hit calculate. There's my next set of toolpaths. Again, we can preview the selected toolpath and just zoom in to double check that's clearing out all the material there. Close the preview form. I'm going to come back up to the profile toolpath, same parameters, hit the selector button, closed vectors. This time we're going to choose top blind dado, check associate with toolpath and hit close, and then again click to select that layer, click to highlight it, Control C to copy, highlight the name down in the toolpath form, Control V to paste, calculate, and there we can preview those last set of profile toolpaths on our dados. Close the preview toolpaths form. Now let's come in and calculate the pocket toolpaths for the next three layers of dados. So again, I'm not manually selecting any vectors. I'm just going to click to deselect any vectors that we have selected in there. Click on the pocket toolpaths icon. In this case, I also want to machine down 3/8 of an inch. I'm going to hit select, choose my 3/8 inch M mill from the tool database, the one that we just set up. But for these pocket toolpaths, I'm going to hit edit and I'm going to change my step over. I want this to be quite aggressive to try and clean out these pockets as quickly as possible, even though we can't do it essentially in a single profile pass like we could with the others, I still want to make sure that we're cutting quite aggressively in here to machine this material out. So I'm going to change the step over to be 1/4 of an inch. I'm going to hit OK. We'll choose the raster option within here, come down and click on the vector selection, closed vectors, back bottom dado. Remember to associate with the toolpath again, hit close, and once more we're going to click again to highlight, Control C, highlight the name down here, Control V to paste, and calculate that. Let's just zoom in on there so we can see the toolpath that's going to calculate for us. We can preview that, make sure it's going to machine out all the material. So that's good. Next we can close the preview and we're going to hit the pocket toolpath icon again. Same parameters should be remembered from before, so then we can just come down, click on selector, closed vector, backside dado, associate with toolpath, close, click over on the name, click again, Control C, highlight, Control V, and calculate. Preview those. Again, just making sure all the material is being cleared out. Close the preview form. Last time we're going to pocket, double check the parameters, hit the selector button, closed vectors, back top dado, associate with toolpath, close, click again, Control C, highlight, Control V, and calculate. And then once more we can preview that to check all those toolpaths look correct. Let's just close the preview toolpaths form. So as we did with the drilling, even though we've got two sets of dados there that are essentially all machined with the same tool and the same toolpath, we've given ourselves the flexibility for maybe changing those parameters in the future by calculating them each as a separate toolpath associated with an individual layer. To finish off now, we're going to do our cutout pass for each of our cabinet components. So to do this, we're going to select the profile toolpath. I need to machine all the way through the material, so I'm going to say 0.75. We're going to use the same tool, this 3/8 inch end mill here. This time though, I want to change my machine vectors to machine on the outside. Very important, I want to cut out these parts, not cut inside them. I'm going to come down, click on the selector button. I'm going to say closed vectors, only those on the layer called cut. Check the box to associate with the toolpath, hit close. This time I don't really need to copy and paste because I can easily type the word cut down here without making a mistake. Go ahead and hit calculate, preview those, and then we can just maximize the 3D view and double check that that is doing as we'd expect and cutting out around each of those different objects that we've got within the part. Can close the preview toolpath form. Now at this point, if we were going to machine this, we could go ahead and save our toolpaths. We could click on each toolpath that used the same tool, click on the button to save, choose the option to output all the visible toolpaths to one file, choose an appropriate post-processor and save that file, send it to the machine and run it. In this case though, what we were looking to do is just create a set of toolpaths that matched a particular setup of data that we're going to get from our cabinet design program to allow us to easily and quickly apply that to future designs. The way that we're going to do that is to save all these toolpaths as a toolpath template. I could save any individual toolpath as a template by selecting it and clicking on the icon here. What we're going to use is this icon here to save all visible toolpaths as a template. What the software considers visible is any toolpath that I have checked, and that is displayed in the 3D view. So every single toolpath that I want to be included in my template, which for me is all of them, I need to be visible. Now I could either individually click each box, or we can use the box above the list here, just check that off and back on again, and when we check it on again it's going to select all the toolpaths in the list and make them visible. I can see them all drawn in my 3D view, and now when I come over and click on the icon here to save all visible toolpaths as a template, it's going to give me the option to do that, and I'm just going to call this sample cabinet.toolpath template, and we'll save that in the project folder. So if we wanted to at this point, we could save the file itself, and that may be useful just to give us a reference point. If we realised we wanted to change something, this would make it much easier to come back and change within the file here and save a new template. So I'll go to File, Save As, and to make sure we don't accidentally confuse this with the other file that we've got in there, we'll just call this template setup.crv and save that in the project folder. Then what I'm going to do is say File and Close. So now what we want to do is load in a different cabinet design that's based on the same setup as our template and apply our template to that new data so that we can automatically generate the toolpaths for it. Now typically cabinet design programs will save a whole bunch of separate DXF files. That may be for each cabinet, or it may even be for each component within the cabinet. So if we take a look at a folder just to show you that, here we can see a design that we've saved, and it's made up of a whole bunch of different individual pieces of our cabinet design. Now it would be quite time consuming for me to load each of these individually into the software, but what we have is a gadget that automates that process for us. So let me just minimize this window here. We'll click on the gadgets drop down menu and I'm going to choose the DXF batch processor. Now gadgets are little routines that have been written to help us with certain features, specifically in this case to automate the importing of DXF files. There's also some for things like rotary setup as well. Here what we need to do is specify a folder where all those files are located. So here we can see I've chosen from the project folder a folder called Cabinet Design Files. I'm going to hit OK, and then what I need to do is tell it either to process just the files in that folder or also to process subdirectories, and then I'll just give it some parameters for how I want to import this data. How many of the individual DXF files do I want in a row, and the gap between the drawings in X and Y. I'm just going to take the values I've got here, 4, 3 and 3. I want to import these into a job which is a standard sheet of material, 96 wide, 48 high, and my thickness is going to be 0.75. I'm working in inches, my origin in the lower left corner, and I want my Z origin on the material surface. Remember, that's what we had our material set up for when we calculated our toolpath templates. So with all that in there, I'm going to hit OK. Software tells me there's no current drawing, so it's going to create one based on the parameters that I set there. Hit OK. Tells me how many files it's imported, so how many files it's processed. In this case there were 56 separate files, and if I hit OK, what I can do is just come to the bottom of the screen here. I'm going to click and I'm going to zoom out by rolling the mouse wheel towards me. You can see there, if we want, I can select all that data, click on the icon to zoom selected, just click off it, and there we can see all those individual pieces that make up this particular design. So there's a lot more parts in this particular layout than there was in our previous one, but they've used the same set of layers, and we want to apply the same toolpaths to each of those layers, and that we're going to be able to do in a moment by using our template. You will notice there's a couple of extra layers in here. Layer 1 we just have as part of our standard file setup within the software, and 0 is often a layer you'll get within a DXF file that has no data on it. We can see which layers have data on by looking to see whether they have a blank piece of paper as part of the layer list here, or if they have these shapes drawn on it. The ones with the shapes drawn on it show me that each of those has some vector data on that particular layer. Now at this stage we've just imported all our shapes into the software. If we're going to load our toolpath template and use it to calculate toolpaths, then I'm going to need to nest my data onto my sheet of material. I can do that by clicking and dragging a box and selecting everything, or I could come up to Edit and choose Select All Vectors, or we have Control A as the shortcut for that. So there we've selected everything. I'm going to click on the Drawing tab and I'm going to click on the icon to nest the selected vectors. Within here I'm going to set up some parameters. I'm going to say that my tool diameter that I want to cut these out with is 3/8 of an inch. I'm going to add some additional clearance in there, 0.25 of an inch. Choose the option to rotate the parts to find the best fit. nest direction or nest from the lower left hand corner, nest direction along Y, hit apply. I want a single copy of each one, and then I can hit preview to see what that's going to do. So there I can see that's nested my data onto 7 separate sheets there. I'm going to hit OK. If you do want to learn more about nesting, then there is a video dedicated to that subject that you can watch. Here I've got my different sheets. I'm going to click on the icon to zoom to fit. When we have nested sheets like this, they will be included in that zoom. Typically when you've got vectors outside of your active work area, then it will always zoom in on the work area, but when you have these sheets, they'll be included to make it easier for you to select on those different sheets. In order to choose a different sheet, we can either go to the Layers tab, and I can click here to choose a different sheet, and what it will do is move the data from that sheet into my active work area. Click here, say sheet 3, or I can just double click, so I can double click 1, double click 4, and it'll just swap those in and out to let me to select which one I want to calculate my toolpaths on. Let's come back to the drawing tab, double click sheet 1 here. What I'm going to do now is click on the icon to switch to the toolpaths tab. That will minimize the drawing tab for me, and now we've zoomed in on our active sheet because we're going to calculate the toolpaths on this. So now we're ready to load our toolpath template and start calculating the toolpath for each of our sheets. To load this, we're going to click on the icon here, Load Toolpath Template. From the project folder, we're going to load the file that we saved, samplecabinet.toolpathtemplate, and hit open. You can see there is the same list of toolpaths that we had before. Now, in order to calculate the toolpaths for a particular sheet of vector shapes, we can just come up and click on the icon to recalculate all toolpaths. Now in this case, we can see this first sheet has only got a limited selection of data on it. So it's telling me that there's an error and that it couldn't recalculate many of the toolpaths, and the reason for that is there's nothing on those particular layers. So we can see that in this case that includes almost all of my toolpaths. If I hit OK, I can see the only one that's calculated is the cut toolpath, and that's because on sheet 1 here we've only got data for that particular layer. So in this case, what I would do is I would just take that toolpath, hit the save button, and I would choose the appropriate post-processor save toolpath, and I could call that cut out sheet 1, or save it into a folder called sheet 1, call the file cut out, or whatever I want to call it so I remember what it is, and save that, and that's all the toolpaths I need for my first sheet of material. So let's just go ahead and hit the close on the save toolpaths form. I may also want to save the software file itself, so I might want to come up to File and Save As and give that a name. Perhaps I would call it whatever the cabinet job was, -sheet 1 or something like that, or maybe I'd save it into a particular folder for sheet 1 under that job name, however I wanted to organise my data, and that would give me a specific reference back to the toolpaths I'd calculated for this if I needed to make an edit to it. In this case I'm not going to do that, but I will show you how to calculate the toolpaths for the subsequent sheets. So we're going to come up to View and Zoom to Drawing so we can zoom out again and see all the different sheets. If I want to calculate the toolpaths for sheet 2, I'm going to double click on it so that that becomes the current data. And what I'm going to do is just undisplay all the toolpaths for a moment. The reason that I do that is when I recalculate the toolpaths, it will only make the ones visible that it's actually calculated, which makes it easier for me to see which ones have been calculated for a particular sheet. So again, I've got sheet 2 is my current set of data, it's my current sheet. I'm going to come up, click on the icon here to recalculate all toolpaths. That'll work its way through the list. It'll tell me if there are any sets of data that I'm trying to calculate toolpaths for that don't exist, so specific layers in this case, and hit OK, and you can see there it's just made visible all the ones that it could calculate. So again, I can work my way through and save those individually as groups of toolpaths, or if I've got a tool changer, save them all as a single file, assuming that I've applied the different tool numbers to the tool names. And for each sheet I would continue the process. So I can double click on the sheet to make it current, uncheck to make sure I undraw all the toolpaths, hit the button to recalculate all toolpaths. Again, it'll display to me the ones that, or the layers that don't have data on for that particular sheet. Hit OK, and the ones that it has calculated will be displayed with a check mark to show that they're visible. Essentially, you just repeat that process for all the sheets of material that you have, saving the appropriate toolpaths, making sure to name them appropriately or keep them within folders so that you're going to be able to run them as sensible groups of toolpaths on your machine. So let's just save our job now in the project folder, go up to File, Save As, and what we'll do is call this particular file cabinet nested-tp to show that it's got toolpaths in it and that it's nested. We'll hit Save. And you can see at this point just how powerful these toolpath templates are. Now, it took us a few minutes to set the template up, but now for any future design that we do with our cabinet design software that has the same set of layers and wants the same set of toolpaths to be applied to those layers, it's going to be very quick and easy to do. It's just a case of importing the DXF file using the batch processor, nesting within the appropriate size pieces of material, opening my toolpath template, and then working my way through the different sheets of material, applying the toolpaths by hitting the Recalculate All Toolpaths button, and then saving those as appropriate. It's worth noting that there are many other applications that would benefit from using the toolpath templates other than just cabinet layout. Anything where you've got different data sets but you're applying the same set of toolpaths to them, so essentially any kind of regular work that you might get where you're just changing names, shapes or something like that, but essentially always doing the same machining operations, would benefit from using the templates. So even things where it appears to be a relatively small amount of work, you might save a lot of time by just putting in a little bit more effort at the start, setting up and saving a template, and then being able to apply that to future jobs. The other benefit of a template, of course, is once you know that it's right, it avoids the potential for mistyping something or making a mistake in a choice that you're making while you're doing your toolpath setup. That concludes this particular presentation.